The curve C has this equation here, for x bigger than or equal to 0. Find dy dx, giving each term in its simplest form. The point P on C has x coordinate equal to a quarter. Find the equation of the tangent to C at the point P, giving your answer in the form y equals ax plus b, where a and b are constants. The tangent to C at the point Q is parallel to the line with equation here. Find the coordinates of Q. Okay, that's the question then. I've got the problem here. So let's get dy dx first of all then. So here, dy dx then. Differentiate, x goes to 1, 2 lots of 1 is 2. X to the half comes down. Minus half of 8 is 4. X to the 1 less than half is minus a half. And the constant goes to 0. So that's equal to 2 minus 4. Drop this underneath and we can write that as x square rooted x to the half underneath, can't we? Because this becomes a half. Flip the sign. So we've done that then. That's dy dx. P has x coordinate quarter. Find the tangent to C at P. So at P, x is equal to 1 quarter, and dy dx on the curve at a quarter is 2 minus 4 over the square root of 1 quarter. The square root of 1 quarter is a half. 4 over a half is 8. Is minus 6. So y is equal to m minus 6 x plus c, because the gradient is minus 6. Okay, it's on the curve P, so at x equals a quarter, y is equal to, let's have a look. So at x equal to a quarter then, put a quarter in, 2 times a quarter, minus 8, the square root of a quarter, was it plus 5? Let's just double check that. Plus 5. X is a quarter, isn't it? Here and here. So 2 times a quarter is a half. The square root of a quarter is a half. 8 times a half is 4. Plus 5. 5 take 4 is 1, 1.5, or 3 over 2. So, what have we got then? Put the value in, 3 over 2, because this is on the curve, is equal to minus 6 times x, which is a quarter, plus c. So that tells us then that c equals, this is 3 over 2 here then, I'm reading it from right to left. Move 6 over 4 is 3 over 2, move it over to plus 6 over 4, which you can write as 3 over 2. So c is 3. That tells us what y is then. Y is equal to minus 6x plus 3. And we needed to write that in the form ax plus b. Y equals ax plus b. So a is equal to minus 6 here, and b is equal to 3. Now the next part, which is part b. Find the tangent to, now we've done that, the tangent to C at Q is parallel to this. Find the coordinates of Q. Tangent to the curve at Q is parallel to this. 2x minus 3y plus 18. 2x minus 3y plus 18 equals 0. So let's get the gradient here. So 3y is equal to 2x plus 18, isn't it? All we've done is move the 3y over here, written it down from right to left. So y is equal to then, divide by 3, all the way through, 2/3 x. 18 over 3 is 6. So the gradient of this line, which is a tangent at Q, is equal to 2/3. So dy dx then must equal 2/3 and it must also equal the derivative. What have we got? 2 minus 4 over the square root of x, isn't it? Here. So it's 2 minus 4 over the square root of x. So what have we got then? Move the 4 over root x over here, and leave the 2 as is, and move the 2/3 over to be with it. So we've got 6/3 take 2/3 is 4/3. So we can see here, for these to be the same, it tells us that x must be 9, mustn't it? Because root 9 will be 3. X is 9 at Q then. And if x is 9 at Q, let's have a look here. So what does the question say? Find the coordinates of Q. So what does y equal? Let's have a look. 2x minus 8 root x plus 5. Y is equal to 2x minus 8 root x plus 5. X is 9, so 2 9s are 18. Minus 8 root 9 is times 3 plus 5. 23, take away 24 is minus 1. So I'll put it up here because of room. So Q has coordinates then 9 and minus 1. That's part C.